In this problem, we need to show that derivative of y with respect to x is given by square root of 2 minus y over y. So here we have been provided with an implicit function. So let's begin with this particular implicit function. We have x equals to 2 times sine inverse of square root of y over 2 minus square root of 2y minus y squared. Now what we'll do, let's label this as number 1. We're going to take the derivative on both sides with respect to y. So that means we have 2 times derivative with respect to y of sine inverse of square root of y over 2 minus derivative with respect to y of, so here we can convert the radical to its equivalent exponent form. So we have 2y minus y squared raised to the power of 1/2. This is done so that we can easily apply the power rule. So that means we have 2 times now derivative of the inverse sine function. For this, we'll have to use the formula derivative with respect to u of sine inverse of u. So that's given by 1 divided by square root of 1 minus u squared. So in this case, u here is represented by square root of y over 2. So we'll use this particular form. So that means we have 1 divided by square root of 1 minus y over 2 because we have taken the square root of y over 2. This will be now multiplied to, we'll have to use the chain rule to derivative with respect to y of the argument of the inverse sine function, which is y over 2 raised to the power of 1/2 minus. Now what we'll do, we'll apply the power rule to get half multiplied to 2y minus y squared raised to the power of half minus 1. Then we use the chain rule to multiply it with derivative with respect to y of 2y minus y squared. Right. So this is the derivative of x with respect to y. Right. Further simplifying, we'll get derivative of x with respect to y will be equals to, so we can take, we'll combine 1 minus y over 2, and there will be also a division by 2 in the denominator. So that means we can have 2 times square root of 2 divided by square root of 2 minus y. In the numerator, in the denominator, this will be multiplied to half. We are using the power rule here. Half multiplied to y over 2 raised to the power of half minus 1. But we'll have to use the chain rule. So we will multiply to derivative with respect to y of y over 2. Minus, we have 1 over 2 times 2y minus y squared raised to the power of half minus 1 is negative half. Then we'll take the derivative of each of the terms within the parentheses to get 2 times derivative of y with respect to y minus derivative with respect to y of y squared. Right. So this will give us, so this 2 and 2 gets cancelled. So we have square root of 2 divided by square root of 2 minus y multiplied to, we have y raised to the power of y over 2 raised to the power of negative 1/2 multiplied to, so 1/2 is a constant, multiplied to derivative of y with respect to y minus 1 over 2. So we'll take this 2y minus y squared raised to the power of negative half from the numerator to the denominator, and we can rewrite it in its radical form as 2y minus y squared under the square root multiplied to 2 times the derivative of y with respect to y, simply 1 minus derivative of y squared using the power rule gives us 2y. Let's further simplify. So we have square root of 2 divided by square root of 2 minus y time. So this can be, we can take the reciprocal to write it as 2 over y instead of y over 2 raised to the power of negative y. So we have 2 over y raised to the power of positive half multiplied to 1 over 2. So derivative of y with respect to y simply 1. So we have 1 over 2 times square root of 2y minus y squared multiplied to 2 times 1 minus y. Right. Now we will have square root of 2 divided by square root of 2 minus y times square root of 2 divided by square root of y times 1 over 2 minus, so here the 2 and 2 gets cancelled. We have in the numerator 1 minus y, and in the denominator we have square root of 2y minus y squared. So this is derivative of x with respect to y. Right. So square root of 2 times square root of 2, so that's 2, and we also have a 2 in the denominator, so they all get factored out, and this leaves us with 1 over, so we'll multiply square root of y with square root of 2 minus y to get 2y minus y squared. minus 1 minus y divided by square root of 2y minus y squared. So this is derivative of x with respect to y. Now since we have a common denominator, we can combine the two numerator to get 1 minus 1 plus y divided by square root of 2y minus y squared. The 1 and 1 gets cancelled, and this leaves us with derivative of x with respect to y equals to y divided by square root of 2y minus y squared. Now what we can do, we can take the reciprocal to get derivative of y with respect to x equals to square root of 2y minus y squared whole divided by y. So we can rewrite it as 2y minus y squared. We'll take this y to the inside of the square root and replace it with 1 over y squared. So that means we now have 2 over y minus 1. So this is the value of the derivative of y with respect to x, and also this is what we were asked to prove. Hence, we have successfully shown that derivative of y with respect to x is equals to square root of 2 over y minus 1.